Hello everyone, today we shall start part 2 of coordination compound. So in part 1 we have studied what are coordination compound, double salt, ligands, different types of ligands, and also we have learned how to find the oxidation state of the central metal ion. So today we shall learn the Iupac nomenclature of coordination compound. So before we start, there are some rules we need to keep in mind while writing the names of the coordination compound. They are rule number 1, to find the oxidation state of the central metal ion. So the first step before we write the name of the coordination compound is to find the oxidation state of the central metal ions. So in order to find the oxidation state, we put X as the value for the metal ions, and then we find the oxidation state of the metal ions. So rule number 2, so rule number 2, if the ligand is negative, the name of the ligand will end with O. So if you have the negative value for the ligands, the name of that particular ligands will end with O. For example, cyanide, the value of cyanide is -1. So it is negative. So cyanide, we write it as cyano. Even bromide is negative. So we write it as bromido. So it's ending with O out here. This is rule number 2. So rule number 3, we have So rule number 3, if the coordination pair is negative, the name of the central metal ion will end with ATE. So if we have the coordination pair out here, so this is the coordination pair. So out here, if you have a negative value, let's say out here we have cobalt. So if the coordination pair is negative, the name of this metal ion will be cobaltate. The name of this element is cobalt. So if the coordination pair is negative, we have cobaltate. So this is rule number 3. So now we shall start writing the name of the coordination compound. So I have written down some coordination compound out here. So we write the coordination compound of each one of them one by one. So first we have KAgCN2. KAgCN2. So the first rule, from the first rule, we have that we are supposed to find the oxidation state of the metal ion. So this is the metal ion out here. So charge of potassium is 1 plus 1, and Ag we are going to put it as X. Cyanide is, since there are two cyanides, so 2 into charge of cyanide is -1 equals to 0. 1 plus X minus 2 equals 0. X minus 1 equals 0. X is equal to plus 1. So the value of X out here, so the oxidation state of Ag is plus 1. So now x equal to 1. So now if you look this compound properly, charge of potassium is plus. If this is plus, the entire coordination entity will be minus. If this is plus, this will be minus. If this is minus, the name of the metal ion, rule number 3, will end with ATE. So we don't have any silverate. We have, for Ag, we don't have silverate, we have argentate. So for Ag, we write argentate. If it is negative, if the coordination pair is negative for Ag, we write argentate. For Au, we write urate. For Cu, we write cuprate. So now we shall write the name. So now whenever there is any element before the coordination pair, if there is any element before the coordination pair, you are supposed to write the name of that element first. So out here, this is the coordination pair and this is the element out here. So before the coordination pair, we shall write this one first. So this is potassium. Potassium. So now after this, we are going to write the name of the ligand. Since there are two ligands out here, and for 2 we have di, and this one is cyano. Dicyano. And for Ag we have argentate. Argentate 1. So the name of this coordination pair will be potassium. For we have 2 out here, so 2 cyano Ag argentate 1. So why did we put argentate ATE? Because the coordination pair is negative. Why this is negative? Because the charge of potassium is positive. If this is positive, the coordination pair will be negative. So next we have K4 NiCN4. K4 NiCN4. So first we should find the oxidation state of the metal ions. So this is plus 1 since there is 4. So 4 into 1 is 4 plus metal ion will be X. Cyanide, there are 4 cyanide. Charge of cyanide is minus 1 equals to 0. So 4 plus X minus 4 equals 0. So X will be 0. Plus 4 minus 4 equal to 0. So X will be 0. So out here we have X equal to 0. So now we shall write the name. So as I've told you earlier, if there is any element before the coordination pair, you're supposed to write that element first. So out here we have potassium and there is 4 potassium out here, 4 potassium out here. But we are not supposed to write tetrapotassium, only the name itself. It doesn't matter if we have 5, 6, 7 out here. Only the name you're going to write first. So out here this is potassium. Potassium. So out here we have 4 cyanide. So 4 will be tetra cyano and this one. So now again potassium is plus, right? The charge of potassium is plus 1. So this is plus. If this is plus, this coordination pair will be negative and the name of the metal ion will end with ATE. So nickel will be nickelate. Nickelate 0. So the name of this coordination compound will be potassium tetracyanonickelate 0. So now the first step, find the oxidation state. So out here we have potassium and there are 2. So 2 into plus 1 is 2 plus X. This is X. Fluoride, there are 6 fluoride and charge of fluoride is minus 1. So we have 2 plus x minus 6 equals 0. So x minus 4 equals 0, x is equal to plus 4. So charge of fluoride is minus 1. So we have x is equal to 4. So in some textbook, they may write fluoro. So in some textbook, they may write fluorido also. So now out here we have potassium hexafluoro. If you want, you can write fluorido. Let's write fluorido. Fluorido. It is ending with O because the ligand is negative. Always remember this one. If the ligand is negative, the name shall end with O. Hexafluorido. Now, if this is positive, this will be negative. Platinum will be platinate. Platinate 4. Potassium hexafluorido or fluoroplatinate 4. Fluorido, it's ending with O because the ligand is negative. The coordination pair is negative. That's why it's ending with ATE. Always keep this one in mind. So next we have K3 FeCN5NO. So now potassium is plus 1, cyanide, charge of cyanide is minus 1, NO is a neutral ligand. So it will be 0. Charge of this NO is 0. It's a neutral ligand. So out here we have 3 potassium, 3 into plus 1 is 3, plus X plus 5 cyanide is minus 1, since there are 5 cyanide, and NO is 0. So 3 plus X minus 5 equals 0, X minus 2 equals 0, X is equal to 2. Out here we have X is equal to 2. So the name of this compound shall be K3. We have potassium. So now we have 2 ligands out here. One ligand, another ligand. So if there are 2 ligands or 3 ligands, you're going to write their name according to the alphabetical order. So whatever names come first according to alphabetical order, you're going to write that name first. So now this is cyanide or cyano, right? So cyano, C, it starts with C, and this is nitrosol. It starts with N, so we're going to write this one first, C first. So pentacyano nitrosol. So now this is plus, the coordination pair will be negative, ferrate. So for Fe is iron. Fe is iron. So whenever the coordination pair is negative, Fe shall change to ferrate. Ferrate 2. So we have potassium pentacyano nitrosol ferrate 2. FeRrate, ferrate. Next we have platinum. So now first we'll find the value of X. This is metal, so X, we have 6. Ammonia is a neutral ligand, NH3 is a neutral ligand, value will be 0. Chloride, there are 4 chloride, and charge of chloride is minus 1. Halogens are minus 1. So X minus 4 equals 0. X is equal to 4, right? This is 0. So we have X is equal to 4. So now again, so whenever there was an element before the coordination pair, we are going to write that name first. And also whenever there is an element after the coordination pair, you're going to write the name of this element at the last. Out here at the first, out here at the last. So now this is the ligand out here. So there are 6. So you have hexaamine, NH3 is amine, 6 hexaamine. So charge of chlorine is -1. So this is minus. If the chlorine is minus, the coordination pair will be positive, right? If charge of chlorine is -1, so this is minus. If this is minus, the coordination pair will be positive. So we have hexaamine platinum. It will not be platinate, it will be platinum, platinum 4, this 4 out here, and chloride, platinum chloride. So the name will be hexaamine platinum 4 chloride. So out here this is a ligand, but since this is a neutral ligand, it's not a negative ligand, so the name shall not end with O, it's ending with its normal name itself. Next we have Na3CO NO2 6. So now first we'll find the value of X amine. So sodium, this is sodium, charge of sodium is 1, since there is 3 into plus 1 is 3, plus X, NO2 is -1, 6 minus 1 equals 0, since there is 6 out here. 3 plus X minus 6 equals 0, X minus 3, X minus 3 equals 0, X is equal to 3. So we have out here X equals 3. So now, as I've said earlier, this one first, Na is sodium. If this is plus, coordination pair will be negative. 6 will be hexa. So NO2. So NO2, for NO2 we have nitrito N, because out here this is making bond using nitrogen. If we have O and O, it will be nitrito O. The value will be same, it will be -1. But if it is O and O, it means that it's making bond using oxygen. If it is NO2, it means it's making bond using nitrogen. So we have nitrito N, nitrito O. So for this one we have nitrito. Since this is negative, right, -1, so it's ending with O, nitrito N, cobalt will change to cobaltate. Cobaltate. Because the coordination pair is negative, so cobalt will change to cobaltate 3. So the name of this coordination compound will be sodium hexanitrito N cobaltate 3. So now this is 3 out here, 3 plus X. C2O4 is -2. So we have equals 0. So 3 plus X minus 6 equals 0. X minus 3 equals 0. X is equal to +3. So now the oxidation state of the metal ion is +3. So out here, right, X is equal to +3. So if this is potassium is plus, coordination pair will be negative. We have potassium 3 tri C2O4 is oxalate. Oxalate. Since this is negative, right, we have -2 out here. Since this is negative, it will be oxalato. Oxalato, it's ending with O out here. And since the coordination pair is negative, iron shall change to ferrate. Ferrate 3. So the name will be potassium trioxalato ferrate 3. So now we shall find the oxidation state. Sodium we have 1, cobalt, we have X. CO is a neutral ligand, so 4 into 0 equals to 0. So 1 plus X equals 0, X equal to minus 1. So we have, so the charge of the metal ion out here is minus 1. So X equals to minus 1. So now this is sodium out here, we have sodium, and then 4 out here. So it will be tetracarbonyls. Tetracarbonyl cobalt. Sodium is plus, this is plus 1, so this will be minus. Cobalt will change to cobaltate, COBALTATE, cobaltate 0. Oh, sorry, cobaltate minus 1. So the name of this coordination compound will be sodium tetracarbonyl cobaltate minus 1. So now we have this one. So fine, this is the metal ion out here, so I'll put it as X. Bromine, there are 2 bromine. Charge of bromine is minus 1. En, charge of En is 0, and chlorine is minus 1 equals 0. So EnX, Br this one, En this one, and Cl this one. So we have X minus 2 minus 1 equals 0. So X minus 3 equals 0, X is equal to 3. So the charge of this metal ion out here is plus 3. Bromine, charge of bromine is minus 1. En, ethylene diamine is 0. And chlorine is minus 1. X is equal to 3. So now we shall write the name. So we have 2 ligands out here. So there are 2 ligands. So as I've said earlier, if there are 2 or 3 ligands, it shall go with the alphabetical order. So out here we have bromide B, and out here ethylene diamine E. B and E. So B shall go first. So we have 2 out here. So it will be dibromido. Since this is negative, so it will end with O. And for En we don't write, since there is 2 out here, for En we don't write di, tri, tetra. For En we write bis, tris. So for bis we, for 2 we have bis, for 3 we have tris for En. So since there is 2 out here, so I'll write bis. Bi is bis. Ethane 1,2-diamine. Ethane 1,2-diamine or ethylene diamine. And then we have cobalt. It shall be cobalt or cobaltate. It shall be cobaltate. Cobalt. Why? Because chlorine is minus, so this will be plus. If the coordination pair is positive, the name shall be the name of the particular element itself. So cobalt will be cobalt itself, cobalt, and then we have cobalt 3 chloride. Dibromido bis ethane 1,2-diamine cobalt 3 chloride. So we have CO, Cl2, En2, 2SO4. So out here, look properly out here, this coordination pair, outside the coordination pair, we have 2 out here. So it means that I'm supposed to multiply the numbers out here to find the value of X. So CO, if I multiply with 2, I will have 2X, and then chlorine 2 to the 4. 4 into minus 1, charge of chlorine is minus 1, 2 to the 4. Again, out here, 4 into En is 0, and sulfate is minus 1. Oh, sorry, minus 2. Plus minus 2 equals 0. SO4 is minus 2. So 2X minus 4 minus 2 equals 0. So 2x minus 6 equals 0. 2x is equal to 6. X is equal to 3. So the charge of the metal ion out here is 3. So now we shall write the name. So while writing the name, we don't need to multiply the numbers anymore, just the ordinary name itself. So now again, alphabetical order, this will come first. Dichlorido, since it is negative. Bis, ethane 1, 2, diamine, ethane 1, 2, diamine, and then this will be SO4 is minus 2. So this is minus, this will be plus. This will be cobalt 3 sulfate. This is sulfate. So the name of this coordination compound will be dichlorido bis ethane 1,2-diamine cobalt 3 sulfate. So now we have PtClNO2 NH3 4 SO4. So we shall find the value of X out here. So X, chlorine is minus 1, NO2 is also minus 1, NH3 is 0, and SO4 is minus 2 equals 0. So X minus 1 minus 1, 0 minus 2 equals 0. So X minus 4 equals to 0, X is equal to 4. So the charge of the metal ion out here is 4. So now we shall write the name. So out here we have 3 ligands, 1, 2, 3 ligands. Since we have 3 ligands, again the rule apply the same with the alphabetical order. So now Cl, this is chlorido, C, nitrito, N, amine, A. So A start first. So I'll write tetraamine. Since it starts with A, we are going to write first tetraamine, chlorido, since the ligand is negative, and this will be nitrito N, NitriTo, nitrito N, and this SO4 is minus, this will be plus, platinum 4 sulfate. So the name of this coordination compound will be tetraamine chlorido nitrito N platinum 4 sulfate. Now we shall find the value of X. Chlorine is chlorine. There are 2 chlorine out here. Charge of chlorine is minus 1. Water is 0. NO3 is minus 1. So X minus 2 minus 1 equals 0. So X is equal to 3. So out here the charge or the oxidation state of the metal ion is 3 plus 3. So now we shall write the name again. So now this is aqua, AQUA. It starts with A, this starts with C. So I'm going to write this one first. So we have tetra aqua dichlorido. NO3 is minus, this will be plus. Chromium 3 nitrate. Chromium 3 nitrate. So we have tetra aqua dichlorido chromium 3 nitrate. So whenever there is a positive sign outside the coordination square, you're supposed to write the value of that plus or minus after the equal to sign. So out here this is X, chlorine, charge of chlorine is -1, ammonia is 0, and equals to, this is +1, so I will write here 1. So X minus 2 equals to 1, so X is equals to 3. So the charge of the central metal ion, or the oxidation state of the central metal ion, is +3. So out here X is equal to 3. So now there are two ligands. We're going to go with the alphabetical order. So we have this is C, this is A. So we have tetra amine dichlorido cobalt 3. So the name of this coordination compound will be tetraamine dichlorido cobalt 3. Next we have COCl En 2 NH3 2 plus. So first we'll find the value of X. Metal will be X, chlorine is -1, En is 0, NH3 is 0, equals to 2. So X minus 1 equals to 2, X is equals to 3. So out here we have X is equals to 3. So there are three ligands out here. So we are going to go with the alphabetical order. This is amine, this is E, and this is C. So this is first. We have amine, chlorido, bis, ethane, 1,2 di, amine, cobalt 3 ions. Sorry, on the previous one I forget to write ions. So whenever there is a charge out here, you're supposed to write ions. So you please correct the previous one. So we are supposed to write ions. So the name of this coordination compound is amine chlorido bis ethane 1,2 diamine cobalt 3 ion. So last we have PT NH3 4 PTCl. Sorry, we have PTCl4. So in this type of coordination compound, so we are going to take as a cationic complex and anionic complex. The cationic complex, we are going to name them first, followed by the anionic complex. So out here, just by looking the coordination compound or the complex out here, we cannot say which one is cationic, which one is anionic. But with the help of a ligand, we will try to figure that out. So out here, this ligand, this is a neutral ligand. So the value will be 0. This will not be positive, this will not be negative. And this ligand out here is negative. Chlorine is -1. So this is negative. So this complex, we will take it as anionic complex. And this one, we shall take it as cationic complex. So first of all, since both the metal ions are platinum, we will take both of them as X. So X plus 4 into 0 plus X plus 4 into -1 equals 0. So X, this one. So X plus X minus 1 minus 4 equals 0. So 2X minus 4 equals 0. 2X is equals to 4. X is equals to 2. So the oxidation state of the metal ion is 2 plus 2. So now we shall write the name. So now this is the cationic complex, anionic complex. So there are 4. We shall write tetra amine. We are taking this one as positive, this one as negative. Tetraamine, this will be platinum 2, and then again we have tetra, I'll just write here tetrachlorido. Since the complex is negative, this name will change. So we have platinate. platinate 2. So the name of this coordination compound is tetraamine platinum 2 tetrachlorido platinate 2. So by this we finish the Iupac nomenclature of coordination compound. So if you have any doubt, you may ask me personally, or you can drop the question in the